Now, from our calculator, we know that the reduced row echelon form of this, we'll just use this as an example, this is slightly different than the one we started with, that this matrix beginning with 40, 200, 400, 660, second row 5, 2, 4, 10, that's different than the one we've been working with, and the final row of 30, 10, 300, and 425, we know that its reduced row echelon form is, actually let me back up, I'm going to change this value. The second row, 5, 2, 4, I'm going to make that 25 to match the example we've been doing. So the reduced row echelon form of that matrix was, as we saw a moment ago, 1, 0, 0, 4, 0, 1, 0, 1 half, third row, 0, 0, 1, 1. Although if we did have some strange fractions, that's perfectly acceptable. Perfectly acceptable in a context. Now express the reduced row echelon form of the matrix as a system of equations and interpret the solution. This first row becomes the equation 1x plus 0y plus 0z, those we don't have to write, equals 4. So x equals 4. The second row is 0x plus 1y plus 0z equals 1 half. Third row is 0x plus 0y plus 1z equals 1. So I've written these as x equals 4, y equals 1 half, z equals 1. And this is an ordered triple, parentheses, 4, comma, 1 half, comma, 1, close parentheses. Now we'd interpret that solution as, going way back, those represent the calories, or the number of servings of each of those food X, Y, and Z. So in this case, we need 4 servings. I'm just going to go back to that previous table. Yes, how many ounces actually was the unit? So that would be 4 ounces of food X. Go ahead and write that. So 4 ounces of X, 1 half an ounce of Y, 1 ounce of Z. That would be the solution to how we can have the right amount of calories, protein, and vitamin C. In our next example, we're going to use our calculator to solve the system of equations. And we have several that we're going to do. But the first thing we want to do is read off the system and write an augmented matrix. So this system of equations, the first equation is x plus 2y plus 2z equals -9. So in our matrix, that's going to become 1 as our first row, 1, 2, 2, -9. So the first row is our first equation. Our next row of our matrix comes from our second equation, which is 3x minus 5y plus 4z equals -64. That becomes the second row of our matrix as 3, -5, 4, -64. Third equation will become our third row of the matrix. 8x plus y equals -3. So this will be 8 for our x term, 1 for y, and 0 for z, then our constant of -3. I'm going to write that as an augmented matrix. Remember, our vertical bar goes right before the constants, so between our third and fourth columns. Now for my calculator, I need to now type this matrix in. Now we've already gone over how to do this. I'll try to walk through it slowly though. I'm going to press second, x to the -1, get the matrix menu. I'll arrow twice to choose edit. That is a 3x4 matrix, so I will leave those dimensions there. They are correct. So enter, enter, and now I can type in my data. I have 1, enter, 2, enter, 2, enter, -9. That is my first row. My second row, 3, -5, 3, enter, -5, enter, 4, enter, -64, enter. Now for my third row, my third equation, 8, enter, 1, enter, 0, enter, -3, enter. I'm going to hit second and then quit to go to the home screen. Now I will choose second matrix again, arrow once to the right, choose math. I want to go all the way down to B, which is RREF. Finally, I need to press second matrix and select under names here, A1 for A, close my parentheses. So I have RREF of A, matrix A, press enter. And in reduced row echelon form, that is 1, 1, or 1. I'm going to rewrite the matrix as first row 1, 0, 0, -1. Second row 0, 1, 0, 5. Final third row 0, 0, 1, -9. Close my bracket. All right, that's an augmented matrix. Now, because I have this in complete reduced row echelon form, my values in the last column actually tell me my solution. My solution is x equals -1, y equals 5, z equals -9. As an ordered pair, or triple in this case, that would be parentheses -1, comma 5, comma -9, close parentheses. That's my solution. Now for my next example, using Gauss-Jordan elimination, which is another name for reduced row echelon form, solve the following system using Gauss-Jordan elimination. I have the equation 3x minus 3y equals 27. And my second equation, 2x plus y equals 3. So in my augmented matrix, this will become my first row, 3, -3, positive 27. And my second row will be 2, 1, positive 3, because that's my second row, or my second equation corresponds to that. Now I'm going to put that in my calculator. I'll bring my calculator on screen so you can see me do it. I'm going to do second matrix, arrow to twice to edit, hit enter. Now this matrix is a 2 by 3. So 2, enter, 3, enter for the dimensions. I'll enter my values, 3, enter, -3, enter, 27, enter. Now for my second row, I have 2, enter, 1, enter, 3, enter. Second quit to go to the home screen. I will choose second matrix, arrow right to math, find B, RREF, hit enter. Second matrix again, and under names I'll select matrix A, which is 1, close my parentheses and press enter. So in reduced row echelon form, that is the matrix 1, 0, 4. That's my first row. 1, 0, 4. The second row, 0, 1, -5. That last column is my solution because I have 1s in the main diagonal, 0s everywhere else. So this means that this corresponds to a solution of x equals 4, y equals -5, or the ordered pair, parentheses 4, comma, -5, close parentheses. For our next example, using Gauss-Jordan elimination, solve the following system using Gauss-Jordan elimination. First equation is -x plus 2y equals 4. Second equation is -6x plus 2y equals -6. So I'm going to write that as an augmented matrix. -1, 2, 4, and that's my final column. Second row, -6, 2, -6. Now, again, I'm going to pull my calculator on screen, type this in. I'll do second matrix, arrow twice to edit. Press enter on matrix A. This is again a 2 by 3, so I'm going to say 2 enter, 3 enter. I'll type in my data. So -1 enter for my first row, 2 enter, 4 enter. Now for the second row, my second equation, -6 enter, 2 enter, -6 enter. Second quit to go to the home screen. And if you notice, the last command we used was RREF of A. I want to do that same function again, so if I press enter, it will recalculate that using the new matrix A that I've typed in. So the reduced row echelon form of this matrix is in the first row 1, 0, 2, and in the second row 0, 1, 3. So again, this corresponds to x equals 2, y equals 3, or the ordered pair parentheses 2, 3, close parentheses. Now our final example, using Gauss-Jordan elimination, solve the following system using Gauss-Jordan elimination. My first equation is 6x minus 3y equals 0, which will make my augmented matrix have a first row of 6, -3, 0. My second equation is x plus 2y equals 5, which will mean my augmented matrix has a second row of 1 for the coefficient, 2 for the y coefficient, and a constant of 5. Now I'm going to input this in my calculator again. Bring that back over here. I'll do second matrix, arrow twice to the right, choose edit A. This is again a 2 by 3 matrix because we had 2 equations and 2 variables. So 2 enter, 3 enter. For my first row, 6 enter, -3 enter, 0 enter. Now for my second row, I have 1 enter, 2 enter, 5 enter. I'll do second quit to go to the home screen, and I'll press enter again to recalculate RREF of A with my new matrix A. Now as we can see, the reduced row echelon form of that matrix has a first row of 1, 0, 1, and a second row of 0, 1, and a constant of 2. This corresponds to x equals 1, y equals 2, or the ordered pair, parentheses 1, 2, close parentheses.